Dear student, warm welcome to NPTEL Phase 2 video course on Geosynthetics Engineering in Theory and Practice. My name is Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay, Mumbai, India. The lecture number is 34. Name of the course, Geosynthetics Engineering in Theory and Practice. This is Module 6, lecture number 34, Geosynthetics for Reinforced Soil Retaining Wall. Now, I will address recap of previous lecture. We covered design of geotextile wrap around face wall. Then in gabion wall, I talk about general and also design of gravity gabion wall that partly covered. Now for the design, we will follow step 2, calculation of the overturning moment, that is overturning moment MO is equal to P of A into Hy by cos of alpha. So this overturning moment you can calculate. You know the Hy, which we discussed also earlier. You know alpha, you know Pa, so you can calculate overturning moment M0. Step 3, calculation of weight of gabion, that is W gabion. W gabion is equal to gamma into G, which is gabion field density into volume of the wall per unit length. Step 4, calculate the horizontal distance of point of application of the weight of the gabion wall from toe, that is H of G. So you have to calculate that what is H of G. That means Hg is equal to A into X divided by A, where A is the individual area of gabion parallel to the slope. So I just mentioned also this earlier that this is the A, that individual area of gabion parallel to the slope, and then you will be knowing what will be the X distance, that means distance of the CG of the individual gabion from the toe, and A is the total area of the gabion wall. You know this length, you know this width, so you can calculate area. So you can calculate what is the H of G. That means Hg is equal to A into X divided by A. Now you can also design for 2 bottom gabion or for 3 bottom gabion or 4 bottom gabion. This is from the geometry. You can solve this H of G for the 2 bottom gabion. This is L, this is width, so you know what is L2 cos alpha into W by 2 into sin alpha plus A into W into L minus A plus A by 2 into cos alpha plus W by 2 into X sin alpha divided by L into W plus A into W. So like this for 2 gabion wall from the geometry of this, from the geometry of the gabion you can calculate that what is for the Hg value for the 2 bottom or for the 3 bottom or for the 4 bottom of the gabion. So like this you can obtain this from the geometry of this gabion. This is similarly for more number of gabion, Hg can also be determined. Now here this W is equal to thickness of each gabion. Each gabion has a thickness, and A, here is the A is the width of the second and the third Gabion, and this is the B is the width of the fourth and fifth Gabion, that is from the bottom, and also the C is the width of the 6 and 7 from the bottom, and D is the width of the 8 and the 9 Gabion from the bottom, and this is E is the width of the 10th Gabion from the bottom. That means top Gabion here as shown, and apart from that there will be the surcharge load. Step 5, at calculation of factor of safety against sliding, then we have to calculate driving force. Fd is equal to Pa minus W Gabion into sin alpha. Resisting force Fr is equal to W Gabion into cos alpha into Ci tan pi. So then you calculate what will be the factor of safety against sliding is equal to Fr by Fd. It should be greater than 1.5. Then it is safe. Step 6, calculation of factor of safety against overturning. So overturning moment m0 is equal to Pa Hy by cos alpha, and resisting moment Mr is equal to W Gabion into Hg. We know Hg, Hy and Pa. So you can calculate what will be the overturning moment as well as resisting moment. So you can calculate what will be the factor of safety against overturning is equal to Mr by m0. That will be greater than 2, then it is the safe. Step 7, calculation of eccentricity E. So E can be calculated, you know, equation L by 2 minus Mr minus m0 divided by Wg cos alpha, and here that it should be minus L by E should be greater than minus L by 6 and less than plus L by 6, then it is okay. So you have to check this. When you solve the problem, we will show you. Step 8, check against bearing pressure. So maximum base pressure developed Pb is equal to Wg cos alpha divided by L into 1 plus 6C divided by L. This should be less than Q of allowable, then it is safe. So Q allowable is the allowable bearing capacity of the subgrade soil. Now I will present an example design of gravity Gabion wall with the following data. The wall height is about H is 10 meter, wall thickness Tg is 1 meter, surcharge load Q is 0 kilopascal, backfill slope angle I is 0, angle of friction between wall and soil delta is 0, wall inclination with the vertical alpha is minus 6 degree, soil friction angle pi s is 32 degree, soil density gamma s is equal to 17 kilonewton per meter cube, Gabion field density gamma g 25 kilonewton per meter cube, because we use the stone. Soil bearing pressure Q allowable is 500 kilopascal and skate correction factor Ci is equal to 0.7, and maximum total base width B is equal to 0.7 H, and as the height of the wall is 10, that means 0.7 into 10 is equal to 7 meter. So base width will be about 7 meter. So these are the data is given for the design of the gravity retaining wall. So here you can see all the data, and here also base is the 7, then after that it is 5, 4, 3, 2, 1 like this. So solution, step 1, calculation of earth pressure and its point of application. So active earth pressure coefficient is equal to K according to the Coulomb's derivation. So you can calculate K using this equation. So you know that pi is equal to 32 degree given, alpha is minus 6, that is why minus 6, and then cos square alpha is minus 6, into cos delta value is 0 and alpha value is minus 6. So, cos 0 plus minus 6 into 1 plus sin pi value is 32, delta value you know 0 and sin pi value again 32, I also is 0. This divided by cos delta, delta value is 0, alpha value is minus of 6 into cos I minus alpha, I is 0. So, 0 minus 6. So, this will give that what will be the active earth pressure coefficient K is equal to 0.27. Therefore, the total active thrust on the wall PA will be equal to K into gamma S into H square by 2 plus QH, that is due to surcharge. So, K you know that 0.27, gamma S is 17, H is equal to 10 meter height of the wall, that 10 square divided by 2 plus this no surcharge we have considered. So, Q is equal to 0 and H is equal to 10. So, you can calculate what will be the total active thrust on the wall PA is 229.5 kilonewton per meter. Now, vertical distance of the point of application of the resultant normal force PA from the toe. So, this PA from the toe you can calculate from this equation, that means HY, you know this equation, I also explained this earlier. So, here H value is given 10 meter given, length is 0.7 times the height 0.7 into 10 7 meter and HV is equal to H cos alpha, that is 10 into cos is 6, that is 9.95. So, if you substitute this value HY is equal to HV is 9.95 divided by 3 into H is 9.95 plus 3 into Q surcharge is 0 divided by gamma S is 17, that divided by HB is equal to 9.95 into 2 into Q 0, this gamma S is 17 minus L is you know 7 meter into sine of alpha is 6. So, if you calculate you can obtain HY value, that is 2.6 meter. So, HY is known to you. So, then step 2, calculation of overturning moment. Overturning moment M0 is equal to PA into HY divided by cos alpha. So, PA you know 229.5 into HY is 2.6 you calculated divided by cos alpha is 6. So, you can have overturning moment MO is equal to 599.99 kilonewton meter per meter. Step 3, calculation of the weight of the gabion. So, weight of the gabion, that means gamma G into volume of wall per unit length. So, you are considering unit length and gamma G is given 25, gamma G is given 25. For example, that this you know HY etc. So, this base gamma G is 25 and volume of the wall per unit width. So, let us say 1. So, this is the 7. Next, this is 5, this is 5. That means 7 plus 5 plus 5. Plus this is 4, this is 4. So, plus 4 plus 4. Then this is 3, this is 3. Plus 3 plus 3. Then this is 2, this is 2. Plus 2 plus 2. And then this is 1 plus 1. So, that means gamma G is 25 into 1 with 1 into this is 7 plus 5 plus 5 plus 4 plus 4 plus 3 plus 3 plus 2 plus 2 plus 1. Which will give you the what will be the weight of the gabion, that is about 900 kilonewton meter. So, you can calculate that weight of the gabion. Now, step 4, calculation of the horizontal distance from the toe to the point of application W gabion. Also, we explain what is Hg, A into x divided by capital A. A is equal to individual gabion area parallel to the slope of 6 degree, and x is equal to distance of the CG of the individual gabion from toe. So, here A total area means 1 into area, I say initially 7, then plus 5, then plus 4, plus 3, plus 3, plus 2, and plus 1. So, area will be equal to 36 meters square. Now, with this equation, so you have to calculate that H of G. So, this H of G you can see here for the 7, 1, this is for 5 and this is for 5, 2, then 4 and 4, this 2, then after that 3 and 3 another 2, then 2 and 2 another 2, and then only 1. So, like this from the geometry of the gabion you can calculate the Hg, and this Hg value will be 5.17 meter. Step 5, calculation of factor of safety against overturning. So, you have calculated overturning moment M0 is 599.99 kilonewton meter per meter, and resisting moment Mr is the what is the weight of the gabion into Hg. That means weight of the gabion you calculated, that is 900. This into Hg you calculated here 5.17. So, which will give you that resisting moment Mr is equal to 4653 kilonewton meter per meter. So, factor of safety overturning is Mr by M0, that means 4653 divided by 599.99, that will give 7.76, which is greater than 2. So, it is safe. So, factor of safety against overturning is safe. Step 6, calculation of the factor of safety against sliding. So, driving force Fd is equal to Pa minus W gabion into sin alpha. So, Pa you calculated 229.5, W gabion is 900 into alpha is equal to 6, so sin 6 degree. So, driving force Fd is equal to 135.424 kilonewton per meter. Resisting force Fr is equal to W gabion into cos alpha into Ci tan alpha. This is the resisting force at the base. So, this is W gabion is 900 into 0.7 into tan of 32 degree. So, this will give you 391.51 kilonewton per meter. So, factor of safety against the sliding will be equal to resisting force Fr divided by driving force Fd. So, this will give 391.51 divided by 135.424, this is 2.89, and that is greater than 1.5. So, it is safe. Step 7, calculation of eccentricity. You know eccentricity is equal to L by 2 minus Mr minus M0 divided by Wg cos alpha. So, hence E is equal to 7 by 2 minus 4653 minus 599.99, you know all Mr or M0 value. This divided by Wg is 900 and cos of alpha is cos 6. So, this will give the eccentricity E value minus 1.03. So, now you look L by 6 value, 7 by 6 is equal to 1.17. Therefore, the minus 1.17, that E should be greater than minus 1.17 and less than plus 1.17. So, that is why it is okay. Now, step 8, check against bearing pressure. Maximum base pressure developed PB is Wd cos alpha divided by L into 1 plus 6 E divided by L. So, Wg is 900, cos alpha divided by L is 7, and 1 plus 6 of E is 1.03 divided by L is 7. So, if you calculate, you can have 240.76 kilopascal, which is less than the key allowable, which is given 500 kilopascal. So, it is safe. So, it is safe against the bearing pressure. Now, here in the Excel form is shown the design of the gabion wall in Excel. If you know the angle of internal friction of the backfill soil, you can put pi as 32 degree. Acute angle of the backfill slope wall with vertical is -6. Wall face inclined with the horizontal alpha is equal to -6. Angle of wall friction delta is equal to 0. Slope angle of backfill soil I is equal to 0. Unit weight of the backfill soil gamma is 17 kilonewton per meter cube. And height of the gabion wall is 10 meter. And width of the wall Tg is 1 meter. And maximum total base L is 7 meter. Surcharge load Q is 0. And scale correction factor Ci is 0.7. And soil bearing pressure Q allowable, that is 500 kilopascal. So, that width of the first layer of the base layer is 7, then width of the second layer is 5 meter, width of the third layer is 5 meter, width of the fourth layer is 4 meter, width of the 5th layer is 4 meter, width of the 6th layer is 3 meter, width of the 7th layer is 3 meter, and width of the 8th layer is 2 meter, and width of the 9th layer is 2 meter, and the width of the 10th layer is 1 meter. So, this way it has been arranged. So, then ultimately if you calculate, you can obtain that coefficient of active earth pressure coefficient Ka is 0.2687, this is almost 0.27, and active thrust on the wall Pa, that is 228.4 kilonewton per meter. You can also calculate the Hy, that is 2.583, and also you calculate Hg is 5.165, and then you can check the stability. So, you can check the stability. You know the weight of the gabion W kg is 900, overturning moment, that is M of O is 593.2. So, you check that what will be also the resisting moment, that is MR is 4648.864. So, you check that what will be the factor of safety against overturning. You know this is the ratio of this. So, this is 7.836, it is greater than 2 is safe. Now, also check the driving force, that is FD 134.2988, and the resisting force FR is 391.5111. So, you check that factor of safety against sliding. So, this will give you that 2.915, which is greater than 1.5, also safe. And eccentricity E is minus 1.03, which is greater than minus 1.166. And maximum base pressure PB, that is 240.8745 kilopascal, which is less than 500. So, it is safe. So, you can check all the stability, that is you can check that what will be factor of safety against overturning, factor of safety against the sliding, and also you have to check that what will be the bearing capacity. So, you can design a wall, gravity wall like this. Now, design of gabion wall with welded wire anchor mesh as a horizontal tie back. Now, here you can see that this is the gabion wall with welded wire anchor mesh as a horizontal tie back. So, this is fixed with the gabion. This is gabion as a facing, and there is a surcharge, and this is metallic mesh as a reinforcement, and this is the failure line. So, we will design this structure, and also this is the failure surface, which is making at an angle 45 degree plus pi by 2, and this is the T of G, and this is the height of the wall Hg, and because this angle is alpha, so this is Hg into tan of alpha. So here that wall height Hg is given, wall height Hg, and wall thickness is the Tg, and surcharge is Q, and backfill slope angle is I, wall inclined with the vertical is alpha, soil friction angle pi, soil density gamma s, Gabion field density gamma g, soil bearing pressure Q allowable, scale correction factor Ci, and maximum base width L is equal to 0.7 into Hg, and ultimate tensile strength is T of ultimate. Now how will you design this? I will show you that design step, and then we will solve one example. Now in design step, you have to go for external stability. So step 1, calculation of the earth pressure and its point of application. So you know that total active earth thrust on the wall Pa is equal to Ka into gamma s into H square by 2 plus Q into H, that is due to surcharge. And K, you know what will be the active earth pressure coefficient. This you know. You know that what is the I, that backfill of the slope angle, delta angle of friction between wall and soil, alpha is equal to wall inclination with the vertical, and pi is equal to soil friction angle. So all values is known, you can calculate that K value. Now when the surcharge is applied over the backfill, the vertical distance of the point of application of the resultant normal force, that is P of A, is P of A from the base, this from the base is H of Y. So here is the H of Y, here Hy. So this H of Y can be calculated with this equation, that is Hg by 3 into Hs plus 3q by gamma s divided by Hg plus 2q by gamma s, where gamma s is equal to soil density, Hg is equal to wall of height. So this is like this, what I said, that this is the P of A, which is this distance is Hy, and this is H of D, and also Pa has the component of Pa cos alpha and also the Pa sin alpha. So we are interested to determine that the value of Hy. So this value of Hy can be calculated using this equation. Now step 2, calculation of overturning moment about 2. So overturning moment m0 again is equal to Pa cos alpha, because horizontal force is acting Pa cos alpha. I show Pa and this is angle Pa cos alpha. That means this is the Pa, this is Pa cos alpha, Pa cos alpha into Hy, this is the moment. So Pa cos alpha into Hy, plus this is the vertical component Pa sin alpha. This Pa sin alpha is equal to, this is Tg, and plus Hy, this is tan of alpha. So this will give the overturning moment. And step 3, you have to calculation of weight of the gabion, W of gabion. That means this W of gabion, this is the Tg, and this also Tg. So it is like a trapezoid. So that means half into Tg plus Tg, and this height is equal to Hg, and this gamma g unit weight of the stone or aggregate. So that means weight of the gabion will be equal to Hg into Tg into gamma g. So you can have ultimately this equation, that W of gabion is equal to Hg Tg into gamma g, where this gamma G is the Gaussian field density, because this Gaussian is filled up with the stone. So you know that what is the Gaussian field density. So you can calculate the weight of the Gaussian. Step 4, calculation of horizontal distance from the toe to the point of application W Gaussian. So here again you can see that what should be the h of G. That means this is T of G, so this will be middle Tg by 2 plus this is Hg tan alpha, that means Hg by 2 into tan alpha, because Tg is equal to wall thickness, Hg is equal to wall height, and alpha is the wall inclination with the vertical. So you can calculate what is the Hg. Hg means this half of Tg by 2 plus half of Hg into tan alpha. Now step 5, calculation of weight of the surcharge. So there will be a surcharge, and that surcharge is Q. So weight of the surcharge Ws will be Q into L. So L is this distance, L is this distance, because surcharge is Q and this distance is equal to L. So weight of the surcharge Ws is equal to Q into L, that means this L. Now how to calculate this L, this L. So this L is equal to, you know the total, this is length L minus this is Tg minus Hg tan alpha. So where L is equal to base width, that is 0.7 times the height of the wall, that is Hg. So you know this value, you know this value, so you can calculate L. So weight of the surcharge is Q by L. Q is given, L you have calculated, so you can calculate what is that weight of the surcharge. Now step 6, horizontal distance from the toe to the point of application of Ws. Now horizontal distance of the weight of the surcharge from the toe of the wall is Hs. So Hs will be equal to, that means you know Tg plus Hg tan alpha plus L by 2. So it is like this, this is Tg plus Hg tan alpha and this is half of this L by 2. So this will give that what will be the horizontal distance of the weight of the what we call surcharge from the toe of the wall. So this will give that value. That means you can calculate what should be the L value, that means L you know the capital L minus Tg minus Hg tan alpha. Now step 7, calculation of weight of the backfill soil, that is W soil. That means W soil will be equal to half into Hg tan alpha into Hg plus 1 L into Hg into gamma of S, because you know that gamma S is equal to density of the backfill soil. So you can calculate what will be the weight of the soil here, because you can see here this is Hg of tan alpha. So this is like a triangle, half of Hg tan alpha into this height is equal to the H. So this plus this, that means this is L and this is that height is equal to Hg, and the unit weight of the density of the backfill soil is gamma S. So this into gamma S into this area into gamma S. So you can calculate what will be the weight of the backfill soil. Step 8, horizontal distance from the toe to the point of application of W soil. So here that again H soil is equal to, you know, Hg square into tan alpha into T of G plus Hg by 3 into tan alpha plus Hg into L into Tg plus Hg tan alpha plus L by 2 into gamma S by W of soil. Where you know W soil is equal to weight of the backfill soil and L is equal to L minus Tg minus Hg tan alpha. So, you can calculate here the horizontal distance from the toe to the point of application of W soil where it is the acting. Step 9, calculation of factor of safety against overturning. So, overturning moment M0 is equal to Pa cos alpha into Hy plus Pa sin alpha into Tg plus Hy tan of alpha. So, you are taking the moment at the toe, you know what is that Pa cos alpha, and you know that like this is a Pa cos alpha, you know this is the Hy, so Pa cos alpha into Hy, you know this is the Pa sin alpha, and this also you can check what also it is acting, this is sin alpha into Tg plus H tan of alpha. So, resisting moment Mr is W of Gabion into H of G plus W of S into H of S plus W of soil into H of soil. That means resisting moment that due to the Gabion and what is the Hg, you know, due to the soil Ws, you know what is distance Hs, also W soil you can also into H of soil you know. So, then you check that what will be the factor of safety against overturning, that is Mr by M0, and it should be greater than 2, then it is safe. Step 10, calculation of factor of safety against sliding. So, driving force Fd is equal to Pa cos alpha. So, resisting force Fr is equal to W of Gabion plus W of S plus W of soil minus Pa sin alpha into Ci tan phi, that is at the base. So, factor of safety against sliding is equal to Fr by Fd, that is greater than 1.5, that means safe. Step 11, calculation of eccentricity E. So, E is equal to L by 2 minus Mr minus M0 divided by W of V. That means E should be greater than minus L by 6 or less than L by 6, then it is okay. What Wv is equal to total vertical downward force over the subgrade soil. So, this will be equal to W of Gabion plus W of S plus W of soil minus Pa sin of alpha. Step 12, you have to check against the bearing pressure. So, maximum base pressure developed Pb will be equal to Wv divided by L into 1 plus 6C by L, that should be less than Q allowable, then it is safe. So, Q allowable, where we can say soil bearing pressure. Step 13, you have to calculate the spacing and the tensile force at each layer. The vertical pressure at any layer, that is sigma z, you know gamma into S into Z plus Q, where gamma S is equal to soil density, Z is equal to depth of the layer from the top of the wall, and Q is the surcharge. Therefore, tensile strength at any layer, that means T calculated, will be equal to sigma Z into Sb into K. So, this you know. So, where Sb is the vertical spacing between the reinforcement, K is equal to coefficient of active earth pressure. Now, provided ultimate tensile strength is equal to T ultimate, hence T allowable should be equal to T ultimate divided by factor of safety. Now, using T allowable is equal to sigma Z into Sb into K, determine the maximum spacing required at the bottom. Getting an idea, assume the suitable spacing of the layer and calculate tensile strength, that is T calculated at any layer. Step 14, check tensile strength at each layer. That means T calculated will be less than T allowable, then it is okay. Or at any layer, T calculated will be sigma z into SB into Ka. This will be more clear when I will solve one example on this type of wall. Step 15, calculation of minimum embedment length, that is LEM, what you call minimum embedment length. So that LEM is equal to Fs into T calculated divided by 2 into sigma z into Ci into tan pi, where Ci is equal to scale correction factor and pi is equal to soil friction angle. So if you know Ci, if you know pi, you know sigma z, so you can calculate what is LE minimum from this equation. Step 16, calculation of actual embedment length, that is L of E. That at the top of the wall, the distance to the wedge failure plane from the back of the wall. That means LA will be equal to Hg tan 45 degree minus pi by 2 minus Hg tan alpha. So it is like this. Suppose if this is the reinforcement, this is the L of E and this part is the L of A. This is L of A. So if this is the LA, if this is the LA, you know this is Hg into tan of alpha. So this L of A will be equal to, this is Hg tan of 45 degree minus pi by 2 minus Hg of tan of alpha. So this will give you what will be the value of L of E. So for at any layer at the depth, any depth Z, the length of the embedment past the wedge, that is L of E, this will be equal to this total length L minus this is Tg minus we calculated L of A, this into Hg minus Z at any depth. If the Hz at any depth, so this will be Hg minus Z divided by H of G. So you can calculate what will be the embedment length from this step. Step 17, check for embedment length. At any layer, the length of the embedment past the wedge is LE. So it should be minimum embedment length LEM, then it is okay. So you have to check. Now this is example. Design a gabion wall with welded wire anchor mesh as horizontal tie back for soil reinforcement, like you say mechanically stabilized earth wall. Now in this example, wall height Hg is equal to 10 meter, wall thickness that is Tg is equal to 1 meter, surcharge Q is 39 kilopascal, backfill slope angle I is equal to 0 degree, wall inclination with the vertical alpha is minus 6 degree, soil friction angle by S is 32 degree, and soil density gamma S is 18 kilonewton per meter cube. So gabion field density gamma G is 17 kilonewton per meter cube, soil bearing pressure Q allowable is equal to 500 kilopascal, and scale correction factor Ci is equal to 0.7 and T ultimate is equal to 60 kilonewton per meter. So maximum total base width L is equal to 0.7 times Hg, that is 0.7 into 10 is 7 meter. So this in this example, this all these data are given. So you have to design a gabion wall with welded wire mesh, anchor mesh as a horizontal tie back for reinforced soil wall. Now, this is a kind of the wall, I say this is the Gabion facing and this is the metallic mesh as a reinforcement, and this is the spacing SB, spacing between the two reinforcement, and this is the surcharge load, this is the Hg, this you know what is L, this is L, this is LE, this is L of A, and this is the failure line which is making at an angle 45 degree plus pi by 2, and this is Tg and this is Hg into tan of alpha. Now for the solution. So step 1, what we have already theory we have explained, and step 1 here calculation of earth pressure and this point of application. So active earth pressure coefficient is K according to the Coulomb's derivation. So this is the K, this is the equation. So from this you substitute this value pi 32, this is alpha minus 6 degree. So you know all this value you have substituted and then you find that Ka value is 0.27. So you know what is earth pressure Ka. Therefore, total active thrust on the wall Pa will be equal to Ka gamma S Hg square by 2 plus Q into Hg. K you know 0.27, gamma S value is given 18 and Hg is 10 square divided by 2 plus Q is the surcharge load is 39 and Hg is equal to 10. So you can calculate that what will be the total active thrust on the wall Pa is 346.6 kilonewton per meter. Now vertical distance of the point of application of the resultant normal force Pa from the base. So you know this equation Hy. So here H of G is 10, this is 10 and this is Hg 10 divided by 3 into Hg 10 plus 3 of Q is you know 30 surcharge and gamma S is 18, this is 18 divided by H is 10 plus 2 into Q 2 into 39 by gamma S 18. So this will give Hy is equal to 3.84 meter. So you have calculated what is Hy, that is 3.84 meter. Now step 2, calculation of overturning moment. So overturning moment, this equation already we have shown earlier, Pa cos alpha into Hy plus Pa sin alpha into Tg plus Hy into tan alpha. Pa you just calculated here, you calculated what is Pa 346.6. So this is Pa is 346.6 into alpha is equal to 6 cos 6. H this Y you calculated here, Hy is 3.84, so Hy is 3.84 plus Pa again 346.6 into sin alpha is sin 6. Tg is 1 is given, Hy you calculated 3.84 into tan of 6, alpha is 6. So if you calculate, then you can calculate the what will be the overturning moment. M0 is 1374.50 kilonewton meter per meter. Step 3, calculation of weight of the gabion. So weight of the gabion, W gabion, you know that we have shown that earlier this equation, that is half into Tg plus Tg into Hg into gamma g, that is Hg into Tg into gamma g. So Hg is 10, Tg is 1 and gamma g is the 17. So this will give the weight of the gabion is 170 kilonewton per meter. Now step 4, calculation of horizontal distance from toe to the point of application of W gabion. So Hg is equal to Tg by 2 plus Hg by 2 into tan alpha. So this equation also shown. So this is Tg is 1 divided by 2 plus Hg is 10 divided by 2 plus tan alpha 6. So this will give Hg is 1.026 meter. Step 5, calculation of weight of the surcharge. So weight of the surcharge Ws is equal to Q into L. L we define. So L is equal to L minus Tg minus Hg tan alpha. That means this is 7, this is Tg is 1, Hg is 10 into tan alpha is 6. So this L will give 4.95 meter. So therefore Ws is equal to Q into L. So Q is 39 surcharge into this L 4.95, this will give 193 kilonewton per meter. Step 6, horizontal distance from the toe to WS. So HS is equal to TG plus HG tan alpha plus L by 2. This we have discussed earlier. So this is TG is 1 plus HG is equal to 10 into tan alpha is equal to tan 6, and L value is this 4.95. 4.95 this divided by 2. So this will give HS is equal to 4.53 meter. Now step 7, calculation of weight of the backfill soil, that is W of soil. That means W soil is equal to half into Hg tan alpha into Hg plus L into Hg into gamma S. So half Hg is 10, tan alpha is tan 6, Hg again 10 plus L we calculated 4.95 into Hg is 10 and gamma S is 18. So this W soil is 985.41 kilonewton per meter. Step 8, the horizontal distance from the toe to W soil. So that means H soil is equal to this equation Hg square by tan alpha into Tg plus Hg by 3 into tan alpha plus Hg into L into Tg plus Hg tan alpha plus L by 2 into gamma S by W soil. Here Hg is 10 square, tan alpha is tan 6 plus Tg is 1 plus Hg is 10 by 3 into alpha is 6 tan 6 plus this is Hg is 10 into L is 4.95 we calculated plus Tg is 1, Hg is equal to 10, tan alpha is equal to 6 and this is L is 4.95 by 2 plus gamma S is equal to 18 divided by this W soil we calculated 985.41. So this H soil will obtain 3.5 meter. So step 9, calculation of factor of safety against overturning. So overturning moment we calculated M0 is equal to 1374.50 kilonewton meter per meter. Resisting moment Mr is equal to W gabion into Hg plus Ws into Hs plus W soil into H soil. That means we know that W gabion 170 into Hg is 1. We calculated Hg is 1.026 plus Ws is 193 plus Hs we calculated 4.53 and W soil is 985.41 and H soil we calculated 3.5. So it will give the resisting moment Mr is equal to 4492 kilonewton per meter. So we can check that what will be the factor of safety against this overturning, that is Mr by M0, that is 4492 divided by 1374.50 is equal to 3.27. So this is greater than 2, then it is the safe. So this we cover the partly with that how to calculate the factor of safety against the overturning when this gabion itself is a facing and facing with the number of the horizontal layer of the metallic reinforcement. Step 10, calculation of factor of safety against sliding. Driving force Fd is equal to Pa cos alpha. Pa you calculated 346.6 into cos of 6. So Fd is equal to 344.69 kilonewton per meter. Now resisting force Fr is equal to W of gabion plus Ws plus W soil minus Pa sin alpha into Ci tan alpha. So W gabion is 170, Ws is 193, W soil 985.41 minus Pa is 36.23 into sin alpha is 0.7, Ci is 0.7 and then the tan of alpha is tan of 32. So this will give that resisting force Fr is 573.96 kilonewton per meter. So you can calculate factor of safety against sliding is equal to what will be the resisting force divided by driving force, that is 573.96 divided by 344.69, that is equal to 1.67, which is greater than 1.5. So it is safe. So factor of safety against sliding is safe. Step 11, the calculation of eccentricity E. So you know that E is equal to L by 2 minus Mr minus m0 divided by W of V. So W of V is equal to W of Gabion plus W of S plus W of soil minus PA sin alpha. So W Gabion is equal to 170, WS 193, W soil 985.41 and PA sin alpha is 36.23. So this will give that W of V is 1312.18 kilonewton per meter. Hence eccentricity E is L by 2, that means 7 by 2 minus M of R, we calculated 4492 minus M of 0, we calculated 1374.50. This divided by W of B. This W of B is 1312.18. So this will give eccentricity 1.124. So now L by 6 is equal to 1.17. So therefore eccentricity E 1.124, which is less than L by 6, then it is okay. Step 12, check against bearing pressure. Maximum base pressure developed PB is equal to WB by L into 1 plus 6C divided by L. That means WB is given 1312.18 divided by L7 into 1 plus 6 into E 1.096 divided by L7. So this is 363.65 kilopascal, which is less than 500 kilopascal, that Q allowable. So this is the check against bearing pressure and it is the shape. So we check against the sliding, we check against the overturning, we check also the bearing pressure. So the wall is so far shape. So with this I finish my lecture today. Any question? Let me hear from you. Thanks for listening.